This is my pre-algebra course. Today you're going to review for the final exam. The final exam is going to cover everything in this course. As usual, we're going to do a practice test together, and then I'm going to give you a practice test for homework. But I want you to be aware that these tests are not the only thing that you need to study to prepare for the exam. You can go back and look at previous tests and also look at the previous content that we learned in the classes. Also, I want you to know that you can use a calculator on this test, and you can also use your sheet with all the geometric formulas on it, and you can also have a sheet with whatever other formulas that you need to use. I'm not going to require you to know by heart all of those formulas. Now, you are going to have to memorize those formulas eventually, but I'm not going to require you to do that in this course. So with that said, let's get started. Problem number 1, find the area of the parallelogram below. So if you get out your geometric formulas, you know that the area of a parallelogram is base times height. So I'm requiring you to write the formula that you're going to use. You must write the formula that you're going to use. And then you're going to plug in what we don't know, and that is the base is 4c cubed, b squared. It's all that stuff at the bottom there. And the height is written on the side there. And there we have it. So all we have to do is multiply that fraction. So when we multiply fractions, we just multiply the numerators. So multiply these. 4 times 3 is 12. C to the third power is just going to stay there, and b to the second times b to the seventh is b to the ninth. And that, then we need the a squared too. All right, now we multiply the bottom. 9 times 8 is 72. And I just noticed that it's probably going to be best to keep these numbers in factored form. So let's just keep that as 4 times 3. And we're using a dot for multiplication. And we'll just keep it 9 times 8, and 8 to the fourth times c, and so that's the bottom. So at this point, all we have to do is simplify this fraction. So you can see that if we factor the 9 and the 8, we have common factors there. So I'm going to factor 9 to 3 times 3, and I'm going to factor 8 to 4 times 2. And I'm going to simultaneously go ahead and reduce these c's. We have c to the third power over c. So we're dividing, so you have to subtract those powers, and you get c to the second power. And there's more c's on the top, so it's going to end up on the top. And we have b to the ninth power, and there's no b's in the bottom, so we just keep that. And a to the second power and a to the fourth power. So just subtract. 4 minus 2 is 2, so we're going to write a to the second power, and there's more a's in the bottom than the top, so that a to the second power is going to end up on the bottom. So now all we have to do is cancel out the common factors and write our final answer, and then we're done. So it looks like we're going to have 2 times 3 at the bottom, which will be 6, and there's going to be nothing at the top except our letters. And there we go. So that's an example of multiplying algebraic fractions. Okay, let me just double check that. Everything looks good. So on to the next problem. It says simplify the following expressions. So we have decimals, so that means you're allowed to use your calculator. 6.1 times 0.87 is 5.307, and it's a negative times a negative, so that would be a positive. Now again, you should probably do these problems on your own before you watch me do them, so you can pause the video and try them on your own. X to the second times x to the fourth, you just add the powers. Now we're adding the powers, you see. When we divided, we subtracted the powers up here. We subtracted, but now we're adding because we're multiplying. And y to the fourth power, so we just added all those powers. And remember to rectangle your answers. On to number 3. Now we're dividing fractions. We multiplied fractions up here in problem number 1, but now we're dividing fractions. So when you divide fractions, remember, you have to take the divisor and flip it and change to multiplication. So we're not going to change to a cross multiplication, we're just going to change and have parentheses for the multiplication. Because in algebra we use parentheses for multiplication. Now, before I do any of that, I just noticed that I should probably rewrite this term. This looks like a whole number term, so we have to write it as over 1. So now we can understand what's going on here. Now we're dividing two fractions. So now we can understand what it means to flip the divisor. So we just rewrite the dividend and flip the divisor and change to multiplication. So now it just becomes a problem where we're multiplying a fraction. So I can already tell I'm running out of room here, so I'm going to try to shrink this here. And multiply the numerators. And we have a negative times a positive, so it's going to be a negative. And then multiply the denominators. But I'm going to go ahead and keep that factored because I see there is going to be a common factor. So now all we have to do is reduce. All right, so equals. Now I'm going to put a divider here because we're getting kind of close to the bottom problems. And 12 we can factor to 3 times 4, and 8 we can factor to 2 times 4. And x to the 5th and x to the 7th we're dividing now, so we can subtract and we'll get x to the 2nd power. Now why did I put x to the 2nd power on the bottom? Because there's more x's on the bottom than on the top. And the y to the 8th, there's nothing to combine with the y to the 8th. So then we cancel out these common factors. And our final answer, I'm going to have to move this over a little bit. I'll be sure to give you enough room so you don't have to mess with this on the actual test. So it's going to be 3. The only thing on top is 3. 5 times 2 is 10, and x squared y to the 8th. Let me just move that over a little bit. So that's the final answer for that one. So 3, 2, 3 over 10, just double checking my answer, and I see we forgot the negative. Now there's no room for the negative on next to the fraction line, so I'm just going to put it in the numerator. That's completely fine. All right, on to the next problem. Number 4, we're just simplifying fractions. This is going to be very easy. Remember, in algebra, a fraction line means division, as we just mentioned. The fraction line means division, so we're dividing 81 by negative 9. 81 divided by negative 9 is negative 9. And a to the 10th over a to the 5th would be a to the 5th on the top. And b to the 9th over b to the 11th, that would be b to the 2nd on the bottom. So that one was pretty easy. Again, I'm sorry I'm not giving you a lot of room here. All right, and 24 over 30. We're just going to have to reduce that by using the fundamental principle of fractions, because if we divide 24 by 30, we're going to get a decimal. So we can divide both 24 and 30 by 6. 24 divided by 6 is 4. And 30 divided by 6 is 5. x to the 6th over x is x to the 5th. Y to the 3rd over y to the 4th is just y. And there you go. Again, where you put the letter depends on which side of the fraction has more letters. All right, so on to number 5. We have another division problem. So with division, again, you just rewrite the dividend as usual. Change to multiplication, which means we can just get rid of that division sign, and flip the divisor. Now we can, now it just becomes a problem where we're multiplying fractions. So we're just going to multiply straight across, but I'm going to leave in the factored form. And c times c is c squared. So I just multiplied the numerators. I'm going to keep that negative there. 10 times ab is just 10ab. Now I'm going to factor, let's see, yeah, I'm going to factor the 4 on the top to 2 times 2. And I'm going to factor the bottom to 2 times 5 because I know that 2 of those 2's are going to cancel out. And we have a over a. Those have the same power, which means they're just going to disappear. And b's have the same power, so they're just going to disappear. So we're just going to be left with c squared on top. And now we have negative 9 times 2 is negative 18. And the c squared and the c squared just stays there. And we have 5 in the bottom. And there you go. All right. On number 6, find the perimeter of the rectangle below. So perimeter is something that you need to remember. Never forget what perimeter is, and don't forget what area of a rectangle or a square or a triangle is. Those things you need to remember for the rest of your life. So perimeter, we just add up all the sides. So I'll write P for perimeter equals 6.2y plus 2.4y, but those are not all the sides, those are only 2 of the sides. Over here we have a side that's this equal length to this side, so that would be another 2.4. 2.4y. Then we have this side, which is equal to the length of this side, so we have another 6.2y. So now we just have to add up all those decimals. And probably the easiest way to do it is 6 plus 6 is 12, 2 plus 2 is 4, 12 plus 4 is 16, and then just add the 0.4, the 0.4, and the 0.2, and the 0.2, and you get 1.2, I believe. So that would be 16 plus 1.2 is 17.2. But you can just use your calculator if you don't feel comfortable doing all that stuff. So I think that's correct. On to part B. Some of these problems are going to have 2 parts. Find the volume of a sphere with radius 3x squared y. So in this problem, we have to get out our formula. Volume of a sphere is equal to 4 pi r to the 3rd power over 3. So, and let's go ahead and move that over a little bit. We want to use as much room as we can. And let's put a divider. Guess I'll move this over even more just to make sure I have enough room. So now we just plug in r. 4 pi and r is 3x squared y. Now, what does it mean to raise this expression to the 3rd power? Well, that just means you're taking that expression and multiplying it by itself 3 times. Why are you multiplying it 3 times? Because there's a 3 power there. And let's just move this over a little bit. don't forget the over 3. So now all we have to do is multiply that expression. Let's multiply the numbers first. Well, actually, we can go ahead and just cancel out 2 of these 3's. Then we're left with 4 times 3 is 12, and then 12 times 3 is 36. 12 times 3 is not one of our multiplication facts, but you can do that off to the side if you want. So now we're done with the numbers. Again, these 2 3's disappeared, so I didn't have to multiply that 3 here. And x squared times x squared times x squared is x to the 6th. And y times y times y is y to the 3rd. And the fraction goes away because this 3 disappeared. There's nothing in the bottom. So we don't need the fraction anymore. Technically, we could write all that stuff over 1, but we just don't need to. So we can just rectangle that. All right, solve the equation below, then check your answer. So we're going to just solve this equation like we normally do, but then we're going to actually plug in our answer and see if this side of the equation actually does equal this side of the equation, which will prove that our solution is correct. All right, so we're going to start by simplifying these x's here. Negative x plus 2x is x. Remember, if it just says negative x, that means negative 1x. And we're going to combine these 2 x's here. So 3x minus 4x is negative x. Now I wrote negative x plus 1, but you could also write 1 minus x. That's fine. But I think I prefer to write negative x plus 1. And so at this point, we need to perform an operation on both sides of the equation to get all the x's on one side. So we have to rewrite that equation. And yes, I'm going to require you to rewrite the equation every time you perform an operation on both sides, unless you have an equation where you have to use the distribution rule with parentheses. All right, so we're going to add x to both sides. You could subtract x from both sides. That would put everything on the left side, or excuse me, the right side, but I'm going to put everything on the left side. Not everything, but the x's, I mean. So now we write the result. Again, these x's cancel out. And so now we're going to perform another operation on both sides of the equation, so we have to rewrite again. And we're going to add 3 to both sides of the equation. And so now we're going to perform an operation again on both sides of the equation, so we rewrite again. I need to get my purple pen out, and we're going to divide both sides by 2. And finally, x is equal to 2. That's the solution, but now we have to check the solution. Now I just want you to be aware that you're probably thinking, well, can I check all my answers to make sure that I get them right on the test? Absolutely, you can check all your answers, but there's one problem. Sometimes your answer is a fraction. So if you have to plug in a fraction, it's going to take a long time to check your answer. Now you can do it. It's not impossible. It's just going to take a lot of energy. And you don't want to waste your energy on the test. All right, so now we're going to plug in 2. We're going to write this exact same equation here, but we're going to plug in 2. So negative 2 plus 2 times 2. Again, I'm just writing the exact same equation that we have here, except instead of x, I'm writing 2. And notice that I'm using parentheses for multiplication. And as usual, I'm running out of room here. Let's put a divider. 4 times 2. So there we go. I plugged in everything. And so now we just simplify. So we've got to use order of operations. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. So again, this side should equal this side. And by the way, don't add something, don't perform an operation on both sides of the equation when you're doing this. All we're doing is just evaluating each side of the equation. Sorry about that. Negative 2 plus 4 is 2, and 2 minus 3 is negative 1. 6 plus 1 is 7, and 7 minus 8 is negative 1. So that checks out. And we can write, yes, the equation works. I guess we can rectangle. I want you to understand that this result here is part of your answer. So I want you to rectangle that and say yes. Or no if it doesn't work. But if it doesn't work, obviously you need to go back and figure out what you did wrong. You need both these parts of this problem to get the full credit for problem number 7, or that same type of problem I'm going to give you on the actual test. All right, so on to number 8. We have an equation with parentheses. So remember, when you have an equation with parentheses, the first step is to get rid of the parentheses using the distributive rule. So we're going to multiply negative 3 times 2y and negative 3 times 3. Negative 3 times 2y is negative 6y. Negative 3 times 3 is negative 9. Now here we have something interesting. There's no number here. But remember, that number is assumed to be 1. It's negative 1. So negative 1 times y is negative y. Negative 1 times 2 is negative 2. So basically that negative sign just changes the signs of the inner parts of the parentheses. All right, let's double check that, make sure we did everything correctly. Everything looks correct. So now we're going to simplify. 5 minus 2 is 3. Negative y minus 4y is negative 5y. So again, all we did was use the distribution rule to get rid of the parentheses. Then we simplified. We have not performed an operation on both sides of the equation yet. So now we're going to perform an operation on both sides of the equation. But remember, I told you when you have an equation with parentheses, I'm not going to force you to rewrite the equation every time you perform an operation on both sides of the equation, because these equations are the longest types of equations that we're going to do in this class, and I just want you to get a feel for what it's going to be like in upper math courses when you don't really have to show or preserve the result of every step. So instead of rewriting the equation, I'm going to go ahead and just add 6y to both sides, and I'm going to get y on the right side, and subtract 3y from both sides, and I'll get negative 12. So not only did I not rewrite the equation, but I showed you the result after 2 steps. So you only have to show the result after performing those operations. Again, this is how you're going to do the problem when you get into upper mathematics, particularly the next course. So now we have y is equal to negative 12, and that's it. We're done. So that was a quick one. All right, now we have an equation with fractions. So we have to get a common denominator. Multiply both sides of this fraction by 2, and you get 2z over 10. So now that allows us to add those fractions. I'm going to go ahead and add these numbers. 4 plus negative 8 is negative 4. All right, so now we can add those fractions. Negative 2z over 10 plus 3z over 10 is 1z over 10, but we don't write the 1, we just write z. And now we have a 2-step equation, but this equation didn't have parentheses, so I'm going to go ahead and make you write or rewrite the equation, because we're now going to perform an operation on both sides of the equation. So now we have negative 5 on the right side and z over 10 on the left side. And go ahead and rewrite, because we're going to perform another operation on both sides of the equation. And remember, we show multiplication with parentheses. Why are we multiplying both sides by 10? We're multiplying both sides by 10 because we have to get rid of this 10, because we have to isolate z. We have to get z by itself. It's not by itself because the 10 is next to it. So we have to get rid of that 10, but the 10 is divided into z. What's the opposite of division? Multiplication. How do we show multiplication? With parentheses. This is all stuff that should just be review for you in this course. If this is the first time you're learning this, that means you didn't actually take my course. You didn't do the homework. And that's a problem. Z equals negative 50. So there you go. Number 9 is negative 50. All right, so now we're going to some more evaluation problems. Evaluation means you're just going to plug in negative 2 to this expression and figure out what the expression equals when negative 2 is plugged in. So we're going to rewrite the exact same expression, except instead of x, we're going to write negative 2. And notice that I'm using a lot of parentheses. You got to use your parentheses properly. That's one of the hardest parts of this course, is using parentheses properly. Let me rewrite that negative 2. There you go. All right, so PEMDAS tells us do the exponents first. So negative 2 to the third power would just be negative 8. And keep in mind, this 4 is not raised to the third power. That 4 has nothing to do with this power. But this does tell us that we're multiplying 4 into whatever this expression is going to be after we raise it to the third power. All right, so then we have, I'm just going to keep, you can do multiple operations at the same time in this particular case, but I'm going to go ahead and do it once at a time. So again, this negative is not raised to the second power. Only that which is in the parentheses is raised to the second power. So negative 2 to the second power is 4. And 4 times negative 8 is negative 32. And 7 times negative 2 is negative 14. Negative 32 minus 14 is negative 46. Negative 46 minus 4 is negative 50. Negative 50 plus 1 is negative 49. So I think that was correct. Let me just double check. Yep, everything looks correct. So if you got negative 49, good job. All right, now we're going to plug in 3. Now notice I didn't use parentheses here. That's because the 3 was positive. I didn't need to use parentheses there. All right, PEMDAS tells us to do the exponents first. 3 to the second power is 9. Now do not add these numbers here. We can't do that. That violates PEMDAS. We have to multiply first. And remember, multiplication is shown with parentheses. Negative 7 times 3 is negative 21. Negative 21 minus 9 is negative 30. And negative 30 plus 8 is negative 22. So if you got negative 22, good job. We have some more evaluation problems. Y equals 1, so plug in 1. I don't need parentheses there because 1 is positive. So PEMDAS tells us to do the parentheses first. We can go ahead and do some of these operations though. 1 to the second power is just 1. And negative 3 times 1 is negative 3. And 2 times 1 is 2. And then here we have 1 minus 1 is 0. So we get 0 over negative 3. 3 minus 2 in parentheses is 1. And now I do need the parentheses because we're multiplying by that 2. This whole power expression is multiplied into 2. So I do need to keep those parentheses. But if it were not multiplied, I could just write 1 to the second power without parentheses, because 1 again is positive. Now if this were a negative 1, then I would have to write parentheses. So these are all very minor things, but they really change the language. If you just add one letter or subtract one letter, or say something in a slightly different way in the English language, you can change the entire meaning. That's just how language works. Well, that's how math works too. You just change one little thing and it completely changes the meaning. All right, so 0 over negative 3, that would just be 0. 1 to the second power is 1. And then we have 0 minus 2 times 1 is 2, and 0 minus 2 is negative 2. So if you got negative 2, good job. All right, now we're going to plug in negative 1. And if this were just positive 1, I would not need parentheses on this part. But since it's negative 1, I do need parentheses to show that we're raising not just the 1, but also the negative 1. If I write negative 1 without parentheses, then we're not raising the negative 1 to the third power. But this statement clearly tells us to raise the negative 1 to power. Not just the 1, but the negative also, because x is negative 1. I know that may be confusing, but you're just going to have to get used to that language. All right, let's double check, make sure we plugged in everything correctly. Looks correct. Now PEMDAS tells us to do parentheses first. So negative 1 plus 3 is 2. Negative 4 times negative 1 is positive 4. Negative 1 to the third power is negative 1. And instead of writing the negative plus negative 1, I'm just going to use condensed notation. All right, 2 to the second power is 4. And then PEMDAS tells us to do multiplication first, so 5 times 4 is 20. And 20 plus 4 is 24. 24 minus 1 is 23. So you can do more than one step at a time, as long as you show most of the work. 14, find d if d is equal to b squared minus 4ac. b equals 2, a equals negative 2, and c equals 1. So this is what's called the discriminant. You're going to use this in my intermediate algebra course, Algebra 2. There's two names for some of these courses. The next course is going to be beginning algebra, but it's also called Algebra 1. And the course after geometry. So it goes this course, and then beginning algebra and geometry and intermediate algebra, but intermediate algebra is sometimes called Algebra 2. Just like beginning algebra is sometimes called Algebra 1. So d squared equals b squared minus 4ac. Now we're just going to plug in the numbers. We're told that b is equal to 2, a is equal to negative 2, and when letters are right next to each other, next to numbers, that means multiplication. So when I actually do plug in the number, I have to write parentheses for multiplication. And c is equal to 1. So now we just have to simplify that expression. So let's double check to make sure we plugged in everything correctly. Everything looks right. 2 to the second power is 4. So I'm just going to do it step by step. Again, you may not have room to do it step by step every time, but negative 4 times negative 2 is, and now you're probably wondering, do we have to multiply these first, or do we multiply these first? Well, remember, by the commutative rule of multiplication, it doesn't really matter. So I'm just going to go ahead and, you know what, I'm just going to go ahead and multiply negative 2 and 1. So then I get negative 2 times 1 is negative 2. And then negative 4 times negative 2 is positive 8. So we end up with 4 plus 8. And then we don't really have much room, so we can go off to the right here, and we get 12. So d is equal to 12. All right, number 15, evaluate your answer for problem number 1 if x equals 2 and y equals negative 1. So we have to go back to problem number 1. So that's problem number 1 there. And I just realized that that doesn't look anything like, there's no x's there. So I changed that problem without modifying the other problem. So we'll just bring that expression down, and let me just modify this a little bit. So we'll paste that down here, and we'll bring it up, and we're going to use that. But instead of x and y, let me say a is equal to 1, It's got to be 1 because it's b. It's actually, let me make a equal to 2. I was thinking of the other letter. A is equal to 2. B is equal to 1. And C is equal to, let's say, 3. So we're going to evaluate this expression here. If A is equal to 2, B is equal to 1, C is equal to 3. So C is equal to 3, so we just plug in 3 for C, and B is equal to 1. Now I can put both of these in parentheses if I want, but I don't need to put both of them. And A is 2. So all we have to do now is just simplify that expression. 1 to the 9th power, that's just 1 times 1 times 1 times 1 times 1 times 1. It doesn't matter how many times you multiply 1, you're just going to get 1. So that just equals 1, and 3 to the 2nd power would be 9. So on the top we have 9 times 1, and 2 to the 2nd power is 4. So we have 6 times 4 on the bottom. 9 times 1 is 9, 6 times 4 is 24. But it looks like we have common factors, so instead of writing 9, well, I guess I can just leave it. There's 2 ways you can do it. You can find the fraction, then reduce afterwards, or you can factor first and cancel out, whatever way you want to do it. But I know that if I divide both these numbers by 3, I'll get 3 over 8. So that's the final answer. Part B, evaluate your answer for problem number 6 if x equals 1 and y equals negative 2. So let's look at problem number 6. So problem number 6 is not the same thing that I have there. So again, I forgot to change that. So let me just copy that. And we'll bring it down. Actually, I do have part B there. So let me just write part B here. Sorry about this. I forgot to change these numbers. So we'll get rid of that. Actually, you know what? I'm just gonna use part A there. So problem numbers. Let me just change that to problem number 6A. Evaluate your answer for problem number 6A. In 6A we got 17.2y. If y equals negative 2. So this is going to be a pretty easy problem. So the perimeter is equal to 17.2y. Because remember that was a perimeter problem. And then you just plug in negative 2 for y. And that would be, I think that should be negative 34.4. All right. So on to number 16. Solve, round to the nearest thousandth if necessary. So now we have decimals. So I'm going to simplify first by combining those x's. Negative 2.7x plus 5x is going to be 2.3x. Again, you can use a calculator for that if you want. And now we're ready to perform operations on both sides of the equation, so we have to go ahead and rewrite the equation. There's going to be a lot of equations on this test because equations are really the most important thing that you learn in this course. So I'm going to add 3.06x to both sides. Remember, there's 2 ways you can do it. You can put all the x's on the left, or you can put all the x's on the right. But I like to keep my variable terms positive, so I'm going to put everything on the left. That's just for this problem. Putting everything on the left side of the equation may not keep the variable term positive. It just depends on the problem. And we're going to have to put a divider here. And let's see here. So we're left with 1 on this side of the equation, and 3.06x plus 2.3x, that would be 5.36x, I believe. All right. I should probably write that much neater. 5.36x. Now we're going to rewrite the problem because we're going to perform an operation on both sides of the problem again, or both sides of the equation. Subtract 3. And now we're going to perform an operation on both sides of the equation again. So I'm going to need to move this equation down. This is the benefit of having a digital notebook with OneNote or some sort of note-taking program, is you can really move stuff around very easily, as you've probably noticed if you've gone through my course. So we're going to rewrite one last time because we're going to perform a third operation on both sides of the equation. Divide both sides by 0.36 or 5.36. And now we have to get the calculator out because that's not going to be an easy calculation. 2 divided by 5.36. And you're probably thinking to yourself, wait a second. How come you didn't put -2 in the calculator? Well, I don't need to do that. I can just write the negative out. You know, I know it's going to be negative. I don't need to put that in the calculator. When you enter a negative into your calculator, that increases the probability that you'll make a mistake when you're entering the numbers into the calculator. But if you want to, you can go ahead and do that. If you want to put the negative in, you would put 2, then you would put the plus or minus, plug in the plus or minus sign, then you would put divided by 5.36, and that will give you the negative. So it says here, round to the nearest thousandth if necessary. Now, if necessary means if the decimal goes on and on and on, and it doesn't stop, then obviously you're going to have to round off. But if the decimal stops, you can write the entire answer. In this case, the decimal is going on forever. We get 0.373134333, so on and so forth. So we're going to round off to the nearest thousandth place. And I'm going to go ahead and use an arrow. Whenever you run out of room, if you do run out of room, you can always use an arrow, and that'll save you. So now x is equal to negative 0.373. Let me move that over. .373134. So I'm just writing a bunch of numbers here. Then we're going to round off later on. So now we're ready to round off. So let's look at the thousandth place. That's here. And the number to the right of the thousandth place in the blue, that's going to tell us whether or not to round up or down. So the 1 obviously tells us to round down. So what that means is we're going to keep that yellow 3. We're not going to make it go up. We're just going to keep it the way it is. And all these numbers are going to go to 0, but because there's ending zeros to the right of the decimal, they can just disappear completely. So the answer for that one is negative 0.373, or negative 0.373. All right, on to number 17. Combine those y's, and we get negative 7y. You know what? I just realized this problem is not even solvable. So I'm going to have to change that. I'm sorry about that. If you were doing this problem on your own, you probably came across something very strange there. I'm sorry about that. Some of these some equations are actually not solvable. We haven't gone over that in this class. That's not something that I'm going to cover in this class. It's not really appropriate for a pre-algebra class, in my opinion, but we may go over that in the next course. Or the next class. All right, so let's see here, we combine these 3's, because if we had negative 3 minus 4y, it wasn't even solvable, so I changed it to negative 3y there. And now we're going to perform an operation on both sides of the equation, so we have to rewrite that equation. And I'm going to have to move all this stuff over. You got to have enough room to write your operations. So now we're going to add 7y to both sides. And we get y over there. And now I'm going to perform the last operation on both sides of the equation. So I got to rewrite again, minus 7 on both sides, subtract 7 from both sides. And we have y is equal to negative 6. All right, so now we have a big old equation with parentheses. So the first step in getting rid of the solving the problem is getting rid of the parentheses. So 2 times 3 is 6. 2 times negative 2z is negative 4z. Negative 4 times negative 2z is positive 8z. Negative 4 times 1 is negative 4. Negative 3 times 3z is negative 9z. Negative 3 times negative 2 is positive 6. And we get 8z. So now we just combine those numbers there. Let's go ahead and check that, make sure we did everything correctly. Everything looks correct. Got to be really careful with these problems. If you make one mistake, your answer is going to be wrong. 6 minus 4 is 2. I'll just put the 2 there. Negative 4z plus 8z is 4z. Z minus, again, this is just z, but it's assumed to be 1z, so 1z minus 9z is negative 8z. And negative 8z plus 8z, well, they just cancel out. So this problem is going to be really easy. So we use the distributive rule to get rid of the parentheses, then we simplified, and now we're ready to perform operations on both sides of the equation. But we're not going to show each step. We're just going to write the result after we perform the steps because we have equations with parentheses. Now, why do we do it that way? That's just my rule for this class. I'm just allowing you to skip steps when you have equations with parentheses. But you can write every step if you want to. I'm just not requiring you to do that. So I'm going to subtract 2 from both sides of the equation, and I'm going to write the result after we do that. So again, I didn't rewrite this equation. I just showed the result after we perform the operation on both sides of the equation. And then I'm going to divide both sides by 4, but I'm not going to show it. I'm just going to write the result after we do it. And there you go. Z equals 1. All right, we're doing good. Find the algebraic solutions and the graphical solutions of the following inequalities. So we're just going to pretend like this is an equal sign, and we're just going to we're going to just solve it. So we're going to have to perform an operation on both sides of the equation, so we have to rewrite the inequality. It's technically not an equation. It's an inequality, not an equation. So we're going to rewrite the inequality, and then we're going to subtract 5x from both sides because we have to get all the x's on the same side of the equation, or the inequality. It's so easy to say equation, but again, it's not an equation, it's an inequality. So now we're left with 1 over here, and negative 5x plus 2x is negative 3x. And let's see here. So now we have to divide both sides by negative 3, so that means we have to rewrite the inequality. Then we can divide, but listen very carefully. Remember what happens when you divide or multiply an inequality by a negative number. When you divide or multiply an inequality by a negative number, you have to flip this inequality sign. So it goes from a less than sign to a greater than sign. And we have x x is greater than negative 1/3. And that is the algebraic solution, algebraic answer. So Now we have to do the graphical solution. So we have to draw our number line, and we'll do 1/3 and 2/3 and so on and so forth. -1/3, -2/3. And let's see here. So it says x is greater than -1/3. So x is the red part, the shaded part. Remember, I always do my lines with red. It just makes it easier to see. So x is greater than -1/3. So -1/3 is here, so we're going to put an open dot because it's not equal to, it's just greater than. And then x is the shaded region, so x is greater than, so that means it's going to be this part over here. But I just want you to be aware, if you don't have a red pen, you don't have to do it that way. In fact, most students are not going to do it that way in actual class. They're just going to write an open dot, and then they're going to shade the region in like that. So you can do that also. But just to make things easier for you to see, I'm going to go ahead and use my red pen. Sometimes it's hard to see if you just shade in with a black pen. All right, so that's the algebraic solution and the graphical solution of that inequality. All right, on to number 20. We have an inequality with parentheses, so whenever you have parentheses, you got to get rid of those parentheses. So -3 times -5 is +15. -3 times -y is +3y. So we use the distributive rule. Again, we multiply -3 times -5 and -3 times -y. So now we're going to rewrite the inequality because actually no, this inequality has parentheses, so we don't have to rewrite. So we're going to subtract y from both sides of the equation, and we get 2y over here. Again, I mean inequality, not equation. Subtract 15 from both sides, and you get 0 over here. So now we're going to divide both sides by 2, and we get y is greater than or equal to 0. Now we did not have to flip the inequality there because we didn't multiply or divide both sides of the inequality by a negative number as we did on the previous problem. So we got 0, and I can write 1 over here and maybe a 2, and you don't really need a specific number of divisions. You can just write a couple there. And so this is going to be a closed dot because it's greater than or equal to. So it's a closed dot right on 0. And y is greater than or equal to, and y is the shaded in part. So because y is the shaded in part, we're going to shade in what's greater than 0. And that is the graphical solution of that inequality. All right, number 21. Graph the following equation, show all work, and identify the points you use to graph the equation. Label your graph properly. All right, first point, second point. The way that we graph a line is by graphing 2 points and connecting the dots. All right, and I'm going to go ahead and draw my axes. X and Y. And I think we're going to need, I'm going to do divisions of 4. That wasn't a very good graph there, so let me move that over. Yeah, this graph doesn't look evenly spaced. So it's gotta be roughly correct when it comes to the spacing. So let me just redo that. Again, it's gonna, sometimes you're just gonna have to redraw your graph. That's okay. So let me try that again. That's a little bit better. It doesn't have to be perfect, but it does have to be relatively, it has to make sense. Obviously, you don't want to spend too much time on this on the test. All right, so I'm going to let x equal 0. So if x equals 0, then we have 7 equals 0 plus y, and therefore y equals 7. So if I use a table here, I'm going to go ahead and write the point also down here. So that's 0, 7 is the point. 0, 7 in the table. And 0, 7 would be about here. Now I'm going to let y be 0. I'm doing it the easiest way possible. So I'm letting y equals 0. Then we have 7 is equal to x plus 0, which means x is equal to 7. So now we have 7, 0. And 7, 0 is about here. And then we connect the dots. And make sure you fill up your window. So that is the graph. And of course, you can write your points next to the actual, or you can draw the coordinates of the points next to the dots if you prefer to do it that way. So you don't have to write your points here, here, and here. You can choose just one of those. You can write your points as ordered pairs on the graph with parentheses, or you can write a table, or you can write ordered pairs down here, just as long as you show those points somewhere. But there's multiple ways to do it, so I'm showing you that there's more than one way. Now, I want you to understand that if I chose the really easy numbers for x and y. But if you choose a numbers different than 0, then, for example, if you choose 1 for x, then that makes it a little bit more difficult because you have to solve that algebraic equation by performing an operation on both sides of the equation. Because you'll end up with 7 is equal to 1 plus y, and then you have to rewrite that equation, and then subtract 1 from both sides, and you get 6 is equal to y. So I chose zeros because they were the easiest numbers to choose. You want to think about what would be the easiest numbers to choose. All right, so that's the answer for that one. On to number 22, graph the following inequality, show all work. This is the same problem, it's just an inequality. Again, we're just going to graph 2 points and connect the dots. So I'm going to let x equal 0. Now we have y, and I'm just going to change the inequality to an equal sign. Because again, we're just trying to find those points. We don't really care about greater than or equal to. 0 divided by 2 is 0, so negative 0 is just 0. And y is equal to negative 3. So that point is 0, negative 3. 0, negative 3. I'll put that in my table. All right, the second point, we have to be careful because this is a fraction. If we choose 1 for x, then we end up with negative 1/2 minus 3. That would be a weird fraction. We have to deal with a decimal. We'd have to deal with a mixed number. So let's choose 2, positive 2. Or we could even choose it might be easier to choose -2, because that would make sure that we stay more within our scale. So I'm going to choose -2. So then we have y is equal to -2 over 2 minus 3. So this is just a double negative. If you take that negative next to the fraction and you put it up here, you can see it becomes a double negative. So that just becomes, but first of all, let's divide -2 by 2. -2 divided by 2 is -1. And then that double negative becomes a positive. And then 1 minus 3 is -2. So the point would just be -2, -2. So now we can write our scale. So it looks like 3 is going to be the biggest number that we need. And again, try to make your divisions evenly spaced. I know it's not easy sometimes, but just try your best. And it looks like this is going to be a dotted line because it's not equal to, it's just less than. So 0, -3, that's down here. And -2, -2, that would be right here. All right, then we have to draw our dotted line. And then we have to do a test point. Remember, we have to do that test point. And I'm going to choose 0, 0 because that would be an easy one to choose. And remember, whatever point you choose, it has to be far from the line. I can choose 0, 0 for 2 reasons. Number 1, it's far from the line. It's nowhere close to the line. And also, 0, 0 is a really easy point to test. Now I could choose a point all the way over here. That would be fine also, but 0, 0 is easier to use. All right, so now to test that point, to test 0, 0, I'm going to plug in 0 for x and 0 for y, and I'm going to determine if that inequality is still true. If it is true, then we're going to shade in this region. If it's not true, we're going to shade in this region. Very simple. All right, so instead of y, we have 0. Instead of x, we have 0. Again, because we're plugging in 0 for x and 0 for y. So now we have 0 is less than -0 over 2 is just 0. And then 0 minus 3 is -3. So you tell me, is 0 less than -3? Now think about that. Is 0 less than -3? It's not less than -3. So because 0 is not less than -3, we have to shade in the region down here. And just do your best when it comes to shading. It doesn't have to be perfect. Again, because this point did not work, you have to shade the other side of the line. But if that point did work, you would shade the side of the line where the point resides. All right, let's go to 23. When a company raised its prices, net monthly profit decreased by 11.3%. You see, if you raise the prices of your products, sometimes fewer people will buy the products, and that will actually decrease your profits. Then it says profit for this latest month was $18 million. That was after the decrease. What was the monthly profit before the decrease? So we have to write our master equation here. The new number, actually I should write that more in the center probably. The new number is equal to the first number minus, because it's a decrease, the first number times the percent written as a decimal. So we know that the new number, n, is 18, and we can write 18. You don't have to write 18 million. You don't have to write this. You can just use units of millions, so we'll write 18. The first number we don't know, but we do know that the percent as a decimal, and again, this R always has to be written as a decimal, is 0.113. Now, remember, when you change a percent to a decimal, you take that decimal and you move it 2 places to the left. And of course, if you're changing a decimal to a percent, you move it 2 places to the right. All right, so I'm going to rewrite this. Because it's traditional to write the number first, then the letter, and that way we can get rid of the parentheses because it reduces ambiguity. So now we have like terms. This is 1F and this is 0.113F. So we can subtract those. It's like 1 apple minus 0.113 apples. So I'm going to get the calculator to do that. 1 minus 0.113 equals 0.887F. So I know that might sound strange, but it's just those are like terms. It's like if you add 2x and 3x and you get 5x. Well, here we have the same thing, but it's instead of x, it's f's. 1f minus 0.113f. So now we have to rewrite the equation because we're about to perform an operation on both sides of the equation. So we want to isolate f. And now we need to get our calculator out. And I'm going to write a squiggly line because I'm going to have to approximate the answer. So 18, I'm using my calculator here, 18 divided by 0.887. And we get f is approximately equal to 20.293, and it just goes on and on. So we're going to have to round off. X is approximately equal to, and let's actually, before we write that, so it says round off to the nearest hundredth of a million. Now be careful because it's hundredth of a million. So again, we're in units of millions, so we don't really have to move the decimal anywhere. So this is the hundredth place. That's a hundredth of a million. And we have to look to the blue number to the right to see if we're going to round up or down. So the blue number is less than 5. So that means we're going to keep the yellow number. And all the numbers to the right of the yellow number are going to become 0. But because those are ending zeros to the right of the decimal, we don't have to write them. So it's just going to be 20.29. And let's see here. I'm going to have to go up and write the final answer up here. So the final answer is $20.29 million, because you have to put the unit, and the unit is millions of dollars. The sum of 4 consecutive even integers is 92. Identify these integers. Now, a lot of students will actually get their calculators out, and they'll actually just try to attempt to add 4 integers and just guess what the integers are. And then they're going to write down the answer if they do find the answer. They might be able to find it quickly. They might not be able to find it quickly. But if you do that and you don't show any of your work, you don't make an algebraic equation to show your work, you're going to get a 0 on my test. So you have to actually show the algebra, so you might as well just do it. So the first integer is going to be x. That's the smallest integer. And the second is going to be x plus 2. Because again, if you're looking at consecutive integers, you just add 2 each time to get the next biggest integer. Because again, they're even integers, so they have to be even. So if you have like 52, for example, the next even number you add 2 to go to 54. All right, so it tells us the sum of all these numbers is equal to 92. So now we have an algebraic equation, and I'm going to write parentheses just to show or just to divide the numbers up so we can see which number is which. Those all add up to 92. All right, so now, again, we don't really need those parentheses because there are pluses in between the parentheses, so we can just get rid of the parentheses. So I'm going to go ahead and do that. And after we get rid of the parentheses, you can see that it's just a multi-step algebraic equation. So we're going to add up all those x's. So we get 4x, because each x just is 1x, and then 2 plus 4 plus 6 is 12. And again, try to keep your equal sign lined up if you can. All right, let's see here. So now we're going to perform an operation on both sides of the equation. So we have to rewrite the equation. And technically these are parentheses, but I'm not talking about those types of parentheses. I'm talking about when you use the distributive rule. So we're going to rewrite the equation each time here. So minus 12 on both sides. And on the right side of the equation, we get 80. And let me move this down a little bit. Now we're going to rewrite the equation one more time. Divide both sides by 4. And we get x is equal to 20. So that's the first number, is 20. So obviously the next number would be the 2 bigger, and 2 bigger again, and 2 bigger again. So that's the final answer. Now you can check to make sure that this is correct very easily. Just add all these numbers and you should get 92. If you get 92, then you know you did it correctly. Now, if you get a number that's an odd number, you know there's something wrong there, because they have to be even numbers. So just be aware of that. Again, you have to show all this stuff on this problem, or else you're not going to get points. And you have to identify, you have to write all this. You have to identify which number is which. All right, so last problem. You take out an $8,000 loan and the bank charges 15% simple interest per month. Over time, your debt grows to $15,200. Assuming that you didn't pay any of the money back, how much time passed since you received the money? So this is just obviously it's a simple interest problem. So we need our simple interest formula. You need to write the formula that you're using. To show which tool that you're using. I can just move this over actually. So now we know A is the amount of money after the certain amount of time. So the account grows to $15,200. We know the principal, that's the amount of money that you put in originally. We know P is 8,000. And we know that R is 15%, but R has to be the decimal form, so we have to change it to 0.15. Now again, if you forgot how to change from a percent to a decimal, you just move the decimal 2 places over. Now you're probably wondering, well, wait a second, where is the decimal? I don't see any decimal there. Well, remember that 15 is a whole number, so that when you have a whole number, the decimal is always directly to the right of the number in the ones place. So it means it's right there. Now, if you don't remember that, or if you don't understand that, that probably means that you didn't take my previous course. Now, if you're rusty on that, just go back to my previous course and look at the class on how to change from a decimal to a percent or a percent to a decimal. That course is a prerequisite. My arithmetic course is a prerequisite for this course. So don't complain if I'm not explaining that, because I'm not required to explain that. You learned that in the previous course. All right, so now we multiply by t, but we don't know what t is. We don't know how long the money has been in the account, so we're looking for t. So this is an algebraic equation. And it looks like it's going to be a 3-step algebraic equation, because the first step is just going to be simplifying. So we're going to simplify. whoops. So I'm going to go ahead and multiply 8,000 times 0.15, and you can get the calculator out if you want to. 8,000 times 0.15 is equal to 1,200. So now we're going to perform an operation on both sides of the equation. So I'm going to have to rewrite that equation. And you can put a comma here if you want, but it's okay if you have a 4-digit number and you want to leave the comma off. That's okay. Now, if you have a 5-digit number, that's not typically allowed. So now we subtract 8,000 from both sides. And we have 1,200t is equal to, that would be, I believe, 7,200. So now we're going to perform one more operation before we get our answer. So we have to rewrite that equation. We're going to perform one more operation on both sides of the equation. And you can see that I'm running out of room, so I'm going to need to move some of this up. Again, I'm going to leave plenty of room for you on the test, so you know what, instead of doing that, I'm just going to shrink everything, because I want to keep my spacing. But remember, try to line up that equal sign. All right, so we're going to divide both sides by 1,200. And t is going to be equal to, I'm going to go ahead and do that in my calculator. 7,200 divided by 1,200 is 6. So the final answer is 6 months. So the money was in the account for 6 months. So that is our first practice exam. Our first practice exam or test for the final test in this course. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for the final test, go ahead and do that now. So here's the homework. Homework is another practice exam for the final test. So get a screenshot of the first 2 pages. And the 3rd and 4th page. And the 5th and 6th page. And the 7th and 8th page. And don't forget to get a screenshot of the answers. You must check your answers. You must do the homework correctly. It's not enough to do it completely. You have to do it correctly. If you don't check your answers, that means you don't care about whether or not you got the right answer. And if you don't care, then you shouldn't be taking this course. All right, so that was this second to last class. We have one more class in this course. So if you've made it this far, I'm proud of you. And the next class is going to be the final test, which is going to cover everything in this course. Remember, these practice tests the practice tests we just did and the practice tests you're going to do for homework, they're not enough to help you prepare for the final. You need to go back to all the previous tests and go back to the screenshots of all the work that we did in the previous classes, and you need to look at everything, or else you may not be prepared completely for the test. So I'll look forward to seeing you in the next class. And remember, do not take that test. Do not take that final test unless you've studied for the test. And when I say study, I don't mean 5 minutes. I mean you need to know how to do every single problem. So do not take that test unless you have studied thoroughly. You want to shoot for a 90 points or above on the final exam. And by the way, I didn't mention that the exam is going to be worth many more points than the regular exams. So you want to do especially well on the final test. So be sure that you can do every type of problem. You want to shoot for a 90% or above on that test. So I'll look forward to seeing you in the next class.